Okay, and lab questions usually have like this one little thing to change at the end. The students are now asked to consider the kinetic energy changes in an inelastic collision. Remember, that means that kinetic energy before the collision is not going to be the same thing as kinetic energy after. They don't match. And in this case, since they stick together, that's totally what's going on. Because a lot of that is probably lost to like internal energy, like, the crumple zones on a car. Okay, the students are asked to consider the kinetic energy changes in an inelastic collision, specifically whether the initial values of one of the physical quantities, it's probably like mass, length, velocity, something like that, affect the fraction of mechanical energy dissipated, used up, in the collision. How could you modify the experiment to investigate this question? Be sure to explicitly describe the calculations you would make, so specifying all equations you would use. And here's the weird part, but do not use any algebra or arithmetic. See, that means you just need to write the equation. Well, see how I just wrote this? Guess what the first thing I'm going to write underneath here is? Okay, so I wrote kinetic energy is mass speed squared over 2. And looking at that, well, I might put in, no, I wouldn't do that. I was going to say I was going to put in subscripts, but I don't think you even need to do that. Basically, I can change the speed or I can change the mass. The mass seems easier to change, especially with Part B since it's just sitting there. Okay, so this is a great answer. The mass of Part B can be varied to compare kinetic energy of the system before, and I noted that was capital K, and the kinetic energy of the system after the collision. And I put that was K prime. But using the equation K equals mv squared over 2, probably didn't need to write that, I could have just done an arrow. And the experimental procedure described above, you could collect data that would allow you to compare K and K prime for several different masses of Part B. That is exactly what they're looking for. Okay, so I want to take you back through how you get points on this. So for Part A, the experimental procedure, having equipment that can make the measurements of the things that you said that you're going to measure the quantities. So time, I've got stopwatches. Displacement, I have meter sticks. And I don't have anything to measure mass. Having that's a point. All right, so having a way to calculate the speed or velocity, which I do right here, that is another point. And having the repeated steps, like that you're going to, have at least 3 trials, evidence of that, and not having any kind of extraneous equipment or something weird, or not specific, like just saying measure with your phone. That's another point. So this first one is 3 points. Okay, so Part B is worth 2 points. You really could have put anything as long as it's not human error. As long as it's the equipment, the table, something like that, and you put a reason. So, oh, my dogs are barking here. Sorry about that. So really anything you put's fine, just as long as it's not like I could mess up the timer or the student could push it, for, I don't know, just not human error. It's not your fault. It wouldn't be a do-over. So, that would be 2 points. So a total of 5 points. All right, so for this one, the graph one, this is where you have the most points. This is where you have the most going on. So you get a point for recognizing that 2 different things happen here. So for a best fit line here, or some kind of indication that you looked for slope before the collision of card A, and some kind of indication that you did best fit line or some kind of slope after. Each one is worth a point. Okay, and you get another point for some application of conservation of momentum. Conservation of momentum with what actually happened, where you have the 2 momentums, or just like momenta, just like one going in here. Basically, you saw that card A had momentum to start off with, card B didn't, and that they combined to have this big momentum at the end. You get a point for that. And then for attempting to plug in the numbers that you got from your best fit line and using only points that are on the line, not like this like guy up here with this outlier. like something that's like somewhat coherent and is within, that can either be rounded up or down to about 1. If you did that, then you would get full credit, and this one is worth 4 points. Okay, so 4 points on that one. Now for this last one, I think I only got 2 out of the 3 points on this one. Here's why. It says affect the fraction of mechanical energy dissipated. I did not explicitly state that I would look at like how much the fraction of each one was. All right, so here's the part I forgot. Using the equation, that equation, I'll put the mass of B can be varied. Basically, I got a point for saying the mass could be varied and for indicating which equation, and that I would use the same procedure as above. That was 2 out of the 3 points. But I kind of missed this part that said a fraction of the mechanical energy dissipated. Well, kinetic energy, since we don't have a spring or gravitational or anything, kinetic energy is the only kind you have, and your initial kinetic energy is the most. It's going to be more than the final. So basically, I put, using that equation and the experimental procedure described above, you could collect data that would allow you to compare the initial kinetic energy and the final kinetic energy to determine the fraction of mechanical energy dissipated. So initial one is, just what the difference is between them, and just over how much you initially had. So how much you lost over how much you had in collisions or several different masses of cart B. So I guess I can't get every single point. That, if you miss one like that, it's not that huge a deal, but I wanted you to know what the right answer was. So that would have been 3 points. So yeah, 3 points for this last part for a total of 12. All the big experimental design questions are 12 points. Focus on analyzing the student's data, and definitely your procedure with always a labeled drawing.